Lesson 51, simplify rational expressions with like denominators. So when we are solving these types of problems, just think of it as either adding fractions or you are simplifying just regular expressions that we've done before. You are factoring out the greatest common factor, if there's a greatest common factor. And then the excluded value, remember the excluded value is what makes the denominator equal to 0. Because the denominator can never equal 0 because we cannot divide by 0. So first we just want to identify the excluded values. So here 3 divided by 5m. For the excluded value, we're only worried about the denominator. So you take the denominator, so in this case 5m, make it equal to 0. Or you could say does not equal 0, and we solve for m. And so to get m by itself, I divide by 5 on both sides. And 0 divided by 5 is 0, so m cannot equal 0. Our next one, we have 5m over m plus 1. So we think of it as m plus 1 cannot equal 0, because if it is, then it's excluded. And that's what we're trying to find. So the opposite of adding 1 is subtracting 1. Whatever I do on one side, I must do on the other. So I have m cannot equal a negative 1. Next problem, we have 5 over 8p. I'm just worried about the 8p because that cannot equal 0. Opposite of multiplying by 8 is dividing by 8. So I divide by 8 on both sides. P cannot equal 0. So I don't know if you notice a pattern here. Anytime it's multiplication in the denominator, the variable cannot equal 0. So just remember that. This next one, 60 over c minus 6. To find the excluded value, I just take my denominator, c minus 6. This cannot equal 0. The opposite of subtracting 6 is adding 6. So I add 6 to both sides. C cannot equal a positive 6. Next one, p plus 4 cannot equal 0. The opposite of adding 4 is subtracting 4. So p cannot equal a negative 4. And so far we've done where it's multiplication, it cannot equal 0. And when it's addition or subtraction, we just do the opposite of it. So do the inverse. And so then you would have either a positive or a negative number that's not a 0. And the last one on this slide, we have 3g minus 15. So I'm going to write 3g minus 15. This cannot equal 0. So this is a two-step process. I need to get 3g by itself, so I add 15 to both sides. And I have 3g cannot equal a positive 15. The opposite of multiplying by 3 is dividing by 3. So I'm going to divide by 3. G cannot equal 5. And we can always check our answer by plugging that number in for the variable. 3 times 5 is 15. 15 minus 15 is 0. Therefore, 5 cannot be what G equals. Next slide. A couple more examples. 12 times h. We need to simplify. Well, for this one, we actually are simplifying and then finding the excluded values. So let's simplify this first. I take 8 over 12. I know I can factor out a 4 and an h in the numerator. 8 divided by 4 is 2. H squared divided by h is h. So that's just a concept we went through already this year. And then at the bottom, I can take a 4h out, and that leaves me with 3 left over. And I can check 4h times 3 is 12h, 4h times 2h is 8h squared. 4 h's cancel out in the numerator and denominator, so I'm left with 2h over 3. And then I look, what can h not equal? Since that is multiplication, I know 12h cannot equal 0. If I divide by 12, h cannot equal 0. So this would be my answer. Next one, 2m minus 6 divided by m minus 3. I know in the numerator I can factor out a 2. 2m divided by 2 is m. 6 divided by 2 is 3. In the denominator I have m minus 3. And what I have in common with the numerator and denominator, m minus 3 and m minus 3. So my answer is 2. But then I also have this cannot equal 0. So to get m by itself, I add 3. So m cannot equal a positive 3. So this would be our answer. And our next problem here, we have 4y squared plus 8y divided by y plus 2. I can factor out a 4y in the numerator. That gives me y plus 2. And in the denominator, I have y plus 2. The y plus 2's cancel each other out. I'm left with 4y. And then we need to find out y cannot equal. Well, if I subtract 2 on both sides, y cannot equal a negative 2. So this would be our answer. So for these types of problems, we're just using what we've already done before, finding excluded values and then simplifying expressions by factoring. Other problems here. We got 6y cubed divided by 24y. The greatest common factor of 6 and 24 is 6. The greatest y I can take out of both the numerator and the denominator is 1y. So 6y cubed divided by 6y is y squared. In the denominator, I can take a 6y out. 24y divided by 6y is just 4. And my 6y's cancel each other off, or they give you 1. So I'm left with y squared over 4. And then y cannot equal 0. And remember, you have to go not only from your answer, but also in the original problem to find out if there's any variables in the denominator. Next problem, g minus 2 divided by 5g minus 10. I can't factor anything out in the numerator, so that stays as g minus 2. The denominator I can factor out a 5. 5g divided by 5 is g. 10 divided by 5 is 2. I know g minus 2 cancels out. That leaves me with a 1 on top. So my answer is 1/5. But g cannot equal. So if I'm subtracting 10, 5g, this has to equal 10. So 5 times what gives me 10? Be 2. So g cannot equal 2. Because 5 times 2 is 10. 10 minus 10 is 0. And this next one here, 7d squared plus 21d divided by d plus 3. I can divide a 7d out. 7d squared divided by 7d is d. 21d divided by 7d is 3. In the denominator, I have d plus 3. The d plus 3's cancel out. I'm left with 7d. And then d cannot equal, but d plus 3 cannot equal 0, so d cannot equal a negative 3. So this would be our answer. So you'll notice that you're trying to, when you're factoring, you're trying to find something that's in common with the numerator and the denominator. Most times, if you have a binomial like d plus 3 in one party, whether it's the numerator or the denominator, more than likely, not always, but more than likely, you're going to be able to find that in the numerator or in the denominator as well. Next problem. Here we have some integer exponents. So we're just going to be doing the same thing. We are adding and subtracting. So treat these as you would normally do with fractions, adding and subtracting fractions. So b over a cubed minus 2b minus a cubed. I need to check to make sure that I have common denominators, and I do. So that means they're all over a cubed. And now I have b minus 2b. 1 minus 2 is a negative 1. And I have a negative 1b here. And there's nothing that I can simplify here. So my answer would be negative b divided by a cubed. And we're not looking for excluded values here, so we would just keep this as our answer. Next one, we have pq to the negative second minus 7p to the negative first q squared. This will make it easier if we get rid of our negative exponents. So if we rewrite this, this should be p on top, q squared on the bottom because it's a negative. To make that positive, we do the reciprocal, minus 7. I don't want that p to the negative first on the bottom, so that's going to come to the top to make it positive. Q squared stays where it's at. Now I have common denominators, and I have 1p minus 7p is a negative 6p all over q squared. So that would be our answer. Next one we have, let's rewrite s to the negative third t. So that would be t over s to the third plus s to the third stays on the bottom. T needs to go on top to make it positive, so it's plus 12t. Now if I add them together, 1t plus 12t gives you 13t all over s cubed. And that would be our answer for that problem. A couple others, 2m over n squared minus m over n squared, common denominators of n squared, so I can subtract. I just have m on top. And the other one, 4f minus 2f is 2f, and the denominators are the same, so 2f over r squared. Now let's get through some application problems. A rectangular field has a length of 6a over 3a plus 4 kilometers and a width of 8 over 3a plus 4 kilometers. Find the amount of fencing needed to enclose all 4 sides. So we are finding perimeter because we want to enclose all the way around. So we have two groups of 6a times 3a plus 4. So I'm going to write that down. I have two groups of 6a over 3a plus 4. And then I'm adding two groups of 8 over 3a plus 4. And when we multiply, you're just multiplying the numerators. So it'd be 12a over 3a plus 4, adding 16 over 3a plus 4. And you might wonder why we're only multiplying the 2 by the numerator, because this is really 2 over 1. And when you multiply fractions, you multiply numerator times numerator and denominator times denominator. Now I have 12a plus 16 all over 3a plus 4. I can now factor this out. I can take a 4 out in the numerator. That gives me 3a plus 4. And then the denominator, I have 3a plus 4. The 3a's plus 4 cancel out. So I would need a perimeter of 4 kilometers. So 4 kilometers of fencing would be needed to enclose that whole field, or that whole yard. And our last one, A rectangular mirror has a frame with length of 2x plus 5 over 4y inches and a width of 6 minus x over 4y inches. Find the perimeter of the frame. So I have two groups of 2x plus 5 over 4y plus two groups of 6 minus y over 4y. So now we can distribute. So 2 times 2x is 4x. 2 times 5 is 10, all over 4y, plus 2 times 6 is 12. 2 times a negative x is minus 2x, all over 4y. And if I want to, I need to combine like terms, so 4x minus 2x is 2x. 10 plus 12 is 22. This is all over 4y. Now I can simplify or factor. I can take a 2 out in the numerator. That gives me x plus 11. I can take a 2 out of the denominator. That leaves me with 2y. The 2's cancel out. So my answer would be x plus 11 divided by 2y. And this would be inches. So as our lesson today, I'm simplifying rational expressions with like denominators.